Any questions on chemical formulas? We good? Yeah, Gavin.
For like doing the real chem and like the examples, so how do we know when I think it's metalloid, like the main body in the middle?
Okay.
How do we know if it has multiple charges, like what charge, like 2, 4, 6, like what they can be? 'Cause sometimes it would give me a metalloid and be like figured out.
Do you mean a metalloid or a transition
Sorry,
metal?
transition metal. Yeah,
Okay.
transition metal.
So let's say we have CuSO4, for example, and you want to know what the charge of copper is, right?
Yeah.
So remember, all ionic compounds must be neutral, right?
Yeah.
So this is the way I do it. There's other ways to think about it. But do we know the charge of sulfate, SO4?
Yes.
We need to know that. It's a 2- charge. Whether you have it memorized up here in your brain or you have a reference sheet that has them on there, your choice. Just make sure you know where to find that charge. Okay? So how many sulfates are there in this particular compound?
Just one.
Just one. Remember that 4 is a part of sulfate. So there's just one. That's a total charge of -2. You with me? And all ionic compounds are neutral. Therefore, the cations have to have a total charge of +2. And since there's only one copper, it's going to take the entire charge. If there's 2, you have to divide it equally into 2, and so on. So that has a charge of 2+. Do you have to memorize what charges they are? No. Nope, you just have to know how to figure it out.
I think if you're asking what I think you're asking, there's a question about the periodic table that's not asking about.
Oh, there was another one too. It was like, what is the charge of platinum?
Yeah.
Is that what you're thinking?
Yeah, and that is just asking in a neutral state on the periodic table. I got super confused and started.
Yeah, if it's platinum, just platinum,
Yeah.
it's just like if it was just carbon
Okay.
or just iron. Just anything has a neutral charge.
Yeah.
Thank you.
Okay, so
I also, yeah.
that makes sense. And then otherwise, we would just still always do a formula like normal.
Yeah.
And then we would have to know that it's a transition metal. And then that way we would know it has multiple charges, so we don't use Roman numerals.
That's right. So what's this one called?
Copper.
Almost. Copper 2,
Sorry.
Roman numeral 2 represents the charge, sulfate. Make sense?
Yeah, thank you.
Yeah. Anything else? Yeah, Leona.
One was a diatomic molecule. Is it every time only if it's 2 molecules of the same?
Yes, and there's only 7 possible diatomic molecules.
Okay, so it can never be.
Yeah, do you want to go over the 7?
I have it.
Okay.
And then the other one was 1 unit of an ionic compound that not be a
1 unit of what?
of an ionic compound. Is it not
Okay.
an ion?
The actual name is formula unit. We will get to that today. And that's not a common name. You've never heard that, I'm sure, right? We just call everything molecules, but they're not. The molecules are the particles of a covalent compound. We're going to get into covalent compounds today. So yeah, there's some things that we haven't got to yet. Any other questions? I just want to make a statement. Looking at everybody's grades, some of you are doing the assignments and some of you are not. your choice, but it will go against you on your grade. So if you don't have Real Chem, you're not registered for Real Chem yet, let's get started on that. So I don't know if I told you, this is the first semester I taught 1210. And so I've been planning for 1210 and making sure I got it all straight. And so I went through the Real Chem. It's really good. I mean, it explains everything, it gives you examples on the way, and you have instant feedback on those examples. Definitely do that. And that's kind of like the pre-reading, right? If you go through that, go through the examples, and because really, if you're waiting to learn it in class, yeah, you're going to learn something, you will. But you have to do the learning, okay? So I would highly encourage you to do those assignments. I know it takes time, it really does. But you got to take time to do well in this class anyway. So spend time doing those real chemistry assignments. Any questions on real chemistry?
Just have a question.
Yeah.
Last time I was early, like 30 minutes early, so
Uh-huh.
I was watching the video on positive organics, but it had no sound. So it was like
Oh, really?
It was like just the screen, but no sound.
Which one was it?
The last lecture.
2.4, the 2.4?
2.4, the last 30 minutes.
Last 30 minutes?
Yeah, I was watching it, but it had no sound. So I was like, I was just following the steps.
All right.
I didn't hear anything, so I was like,
I'll try to repost that. Thank you. If you send that in email, I'll for sure get to it, if you wouldn't mind. Okay, thank you. Anything else? All right. So any questions about diatomic molecules? There's 7 of them. We got these down? Hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. So H2, N2, O2, F2, Cl2, Br2, I2. Good? There you go. If that doesn't scare you, great. I'm scared of it. All right. Well, let me just do one example just to kind of refresh us a little bit. Let's say we have SRX, a compound, strontium with some element in it. And we know X is a diatomic molecule. Do we understand how to determine what X is? So we're going to do something similar to Gavin's question. Well, kind of similar to what we talked about. Maybe that wasn't his question, but do we know the charge of any of those?
SR2+.
Yeah, strontium is 2+, and there's only one of them, so that's +2. This side has to be -2, and there's only one X. That means it's a 2- charge, right? So what diatomic molecule has a 2- charge? Oxygen, right? We good? What if it said X is a solid at room temperature? Then what would you guess X would be? What are the possibilities? It's no longer a diatomic molecule. So what are the possibilities of X if it has a 2- charge? Anything in group 2, right? Is it oxygen? How do you know?
It's not solid.
Oxygen is a gas at room temperature. So what would you guess? Maybe sulfur, right? And maybe we wouldn't even know that, right?
Yeah, I don't know.
Okay, and that's okay. So I might give you some other conditions here, besides it's a diatomic molecule. Good?
What are the conditions? The weight or atomic number, or maybe that was too. Protons?
It's a great question. I might say it's a gas at room temperature. Then you would know this is what?
Oxygen.
Because we know oxygen is a gas. Okay? I wouldn't give you one that, okay, you have to know a little bit more. Okay? All right, today let's talk about the covalent compounds. That's where we ended last time, right? Okay. Okay, first of all, how do we know if a compound is ionic?
It's charged?
It's not charged. All ionic compounds must be neutral, right? Okay, good. How else do we know it's an ionic compound? It's made of a cation and an anion. Good. What else? The easiest way. Metal and a nonmetal. How do we tell if it's a covalent compound? That's it. It's composed of two nonmetals. So let's know this. Composed or made up of two nonmetals. Now, in this class, we're going to do binary ionic compound or covalent compounds. What does binary mean? Two different atoms, two different elements. Bi means two. It also two also means di. We're going to learn about that. Why? Why do we do it different? To make it hard, because this is science, right? No, I don't know why, but anyway, maybe different language. I'm not sure. So covalent compounds are made of, when I say binary, there's only two, so two nonmetals. We can have covalent compounds that are made of more than two nonmetals, but just nonmetals, right? So if you take higher chemistry, like organic chemistry, then you get into compounds like C3H8O. That's three nonmetals, right? But again, it's nonmetals. So we could just say it's just composed of nonmetals. Good? We're not going to have to worry about that in this class. Well, kind of. I won't have you name that. All right, another thing you need to know. We said ionic compounds are solids at room temperature, crystalline solids at room temperature, right? Covalent compounds, can you have a crystalline solid at room temperature? Yeah, like sugar. Sugar is a covalent compound, it's a crystalline solid. But then we have, like this one right here, C3H8O. Well, that's a liquid at room temperature. That's isopropyl alcohol, rubbing alcohol. We could have a compound, well, let's see, CH4. That's methane, that's gas. So covalent compounds are kind of all over the board. Solid, liquids, and gases. And then another thing you need to know is they have low melting points and boiling points. Why is that? Ionic compounds have high melting point, boiling points. Covalents have low. What causes that? Any ideas?
Is that because the chemical bonds are weaker?
The bonds are weaker. Well, yeah. Okay. What makes them weaker?
Because they're covalently bound by sharing electrons, is that why?
Actually, we'll get into that.
Okay.
But yeah, they are weaker bonds. Yeah, weaker bonds. That's the best answer. Okay. Low conductivity, even when dissolved. Can be charged. What's an example of this? We learned last time. What do we call a charged covalent compound? Polyatomic, right? You remember these? Anybody study these and get these down yet? Get there. I mean, you can just put them on your reference sheet. That's okay. Right? Your reference sheet for the midterm and the final, one whole page, both sides. So if you want to just put it on there, be my guest. Okay? But if you're going on further, I would get them down. When I say further, I mean higher courses of chemistry, right? I would get them down. Okay? Okay, what do we do with the electrons in an ionic compound? Anybody can tell me that? They're transferred. Electrons are transferred. In a covalent compound, they are shared. Electrons are shared. To form what?
Covalent bonds.
Sure. To form an octet. We talked about what an octet is, right? Where atoms tend to gain or lose or even share electrons to achieve the electron configuration of a noble gas. We didn't talk about electron configurations yet, did we? We're going to do that next time. Well, either next time or the next time after that, in chapter 3. Okay? When I say chapter, I mean unit 3, module 3, whatever we call it, right? Any questions how you determine whether a compound is ionic versus covalent? Gavin?
So in biology 1610, we went a lot over like ionic and covalent bonds, and I haven't seen it in this course, so I'm wondering, they use a lot like electronegativity, and like if the electronegativity between a bond was like a certain ratio, like I think if it was like under 0.6, it was like hydrogen. If it was like around 0.6, it was covalent. If it was above like 1.1, it was ionic.
We'll get there.
Okay, so that's like
Yep.
gonna happen.
Yep, we will get there.
Because I felt like that was an easy way to know.
Yeah. That's an easy way if you have the electronegativity values.
Right, exactly. You have to have that.
And let's see. I can give you a chart again. I won't give that to you on the exam. If you want to put it on your cheat sheet or well, if on the unit exams you can use it definitely if you have a paper copy, right? So yeah, I will give that to you. Anything else?
What's the last word you wrote? To form a what?
Octet.
Octet.
What's an octet?
Is that filling the valency shell to 8?
Yeah. Atoms tend to fill their shell or remove all the electrons to have a full shell. Does everybody understand that, or do I need to draw pictures? I can. Jot?
No, I think you went over it
Yeah. So if anybody needs a reminder, let me know, because this is important for the rest of the course. Yeah.
I'd like a reminder on how you distribute your electrons.
So the Bohr model,
Yes.
okay, the Bohr model is not exactly how the atom looks.
Right, it's just how we
But-
choose to represent it. But when you draw the symbol and the dots around it, that's
So if I have carbon, how many valence electrons does carbon have? 4. It's in group 14, so it's 4, right? Or 4A. So it has 4 valence electrons. There they are. We don't pair them up until we have to. And that really is a rule when we get into the modern mechanical model, quantum mechanical model. Next section. Okay. Is that what you wanted? Or did you want the Bohr model too?
no, that was the model I
Okay.
had in mind. Then how, as you add more electrons, what is the order in which they pair? Do you go like in a counterclockwise
It
motion?
really doesn't matter. Because this is not how they look anyway. This is just a model to help us to put it together. Okay? And we will get there. So we'll talk about the structures a little bit later. Not today, but later. Good? Okay, let's talk about how to, any questions how to name ionic compounds? If it's a main group element, we use the element name of the cation first, change the element name of the anion to IDE, and that's it, right? Do we remember that? Okay. And if it's polyatomic ions, we use the polyatomic ion name, right? If it's a transition metal, we have to figure out what the charge is of that metal and put the charge in parentheses as a Roman numeral number. We good? And that's just for the cation, because metals are cations, right? Okay. So let's talk about how to name covalent compounds. So just like ionic compounds for main group elements, we're going to name the first atom in our covalent compound, just the element name. The second atom in our compound, we're going to change the ending to IDE. Same way. Because all nonmetals are main group elements, aren't they? There's no cations and anions, so we just, the first element listed in our compound, we just use the element name. Good?
Mind if I close the door?
Oh yeah, please do. We just put the little rubber stopper inside the class. Thanks. All right, so step 1, name first element as element name. And here's where it's a little bit different. And use the correct prefix. We'll talk about prefixes in a minute. You guys all know what a prefix is, right? Right before the name, okay? Step 2, name the second element by changing ending to IDE. Or suffix to IDE, right? Ending. And use the correct prefix. Okay, that's it. We're done. That's it. So let's get the prefixes down. Prefix for 1 is mono, kind of like monotone, right? You ever hear a monotone singer? They think they're, you ever hear people that they think they sound amazing, think, whoa. Okay? And they're just, Mary had a little lamb, they never changed the tone of their voice. Monotone, one tone, mono. Good? So, anyway. Number 2 means, or the prefix is die, kind of like dicicle, right? I don't know. Yeah, go ahead, Michael.
I was just wondering if the second element is a polyatomic ion, do you
Then-
choose the I as well?
Then it will be an ionic compound every single time. Are we good? So that's a good way to determine if it, because sometimes you have an ionic compound that does not have a metal in it. For example, if ammonium, NH4 plus, is the cation, right? Then there's no metal in it. But it's made of polyatomic ions, therefore it's an ionic compound. Good? Glad you brought that up. Okay? And the rest of them are a little bit more straightforward. I don't know why we use die. I don't know why we just don't use just bi. I don't know. But here we go. So 3 is try like triangle. 4, this one might not be amazing, but here we go. You guys ever play Tetris? And Tetris is made of all of the pieces that you have to put in where they go, to make the solid block or whatever. Then all of the pieces are made of 4 pieces, yeah? 4 cubes, 4 squares. And, well, Tetris or tetra is 4. 5 is like a 5-sided polygon called a pentagon or penta. 6, same thing, hexagon. 7, not very common, but is hepta. 8, like an octopus, 8 legs, octa. 9, again, not very common, nona. And 10, deca. We good? Should we see if we're good? There we go. What's that called, everybody? Carbon dioxide. Maybe we knew that before this class, I don't know. But this is carbon. Oh, hold on. Why don't we call it monocarbon?
Well, because you don't say the mono.
We don't use mono for the first element only. Write that down. So we'll put in here, don't use mono. Just for the first element. We can use it for the second one. So we're just going to use element name, carbon, and oxygen. There are 2 of them, so we're going to use di. We're going to change the ending of oxygen to IDE. Good? What about CO? What's that called? Carbon monoxide. We do use mono for the second element. Notice we don't say monooxide. Why? Because it looks like monoxide. We don't do that. Okay? Two vowels in a row, we kind of just drop one, right? What if the other vowel's an A? We drop it so that we know what we're talking about. Like decaoxide, decoxide. And we still need it to be oxygen, right? So we're not going to say decaxide. You with me? Okay, what about N2O5? Everybody name it without saying it out loud, just so that you can do it. without saying it out loud so that that way everybody gets a chance. No. I'm just kidding. Sorry, that was rude of me, wasn't it? All right, who wants to tell me what this is called? Katrina doesn't want to now. I just
Dinitrogen pentoxide.
dinitrogen pentoxide. Yep. If you said dinitrogen pentoxide, would I mark you wrong? No, because our tests are multiple choice, and that's not one of them, right?
What if that's one of the choices?
Then it's a bad test question. And again, I'm on your side. If that's one of the questions, you let me know, okay? Or one of the options, okay? All right, what about, let's write the chemical formula for tetraphosphorus dicoxide. Can you do that without me telling you how to write chemical formulas? You can tell me if you want.
Yes.
What is it?
Oxygen 10.
There you go. That pretty straightforward, guys? A little bit easier than ionic compounds? Until we get to organic chemistry. Then it gets a little bit tricky. So we're not going to do that in this class.
Praise be.
Anybody taking organic chemistry later? Okay, you'll learn it. It's cool, but it's just a little bit more intensive. Okay. All right, on this, so on the worksheet that I gave you last time, not this time, then there's practice for, let's see. Anybody need one? Yeah, come grab one if you need one. So the back side, on section 10, section 9 just says determine the type of compound. That's a pretty good exercise for you. If you're given the compound, you should be able to say which type it is. Or given some properties, you should be able to tell which type it is. But anyway, right now we're doing section 10. Unless this is pretty straightforward and we're ready to move on. Yeah.
Is the worksheet from today on the canvas?
Maybe I didn't put it there yet.
Okay.
My bad.
I don't see it.
I'm making these as I'm going. So, didn't quite put that on there, I don't think. I thought I did, but maybe not.
Okay, 'cause it's just a continuation of last week's, right? Yeah.
Yeah,
Yeah, the one on the campus ends at 10.
okay. How are we feeling? Any questions on section 10? Any that look kind of All right. Let's move on to acids. How do you tell if a compound is an acid? Does anybody know this? Yeah,
If it has, hydrogen,
almost. Not if it just has hydrogen. Is water an acid? If we get real deep inside, then it could act as an acid, but it could also act as a base. So, okay. But we don't necessarily say water is acidic, right? We say water is neutral. But water has H in it, so that's not an acid.
Is it missing an electron from its outer shell?
Oh,
Not quite.
Isn't it at hydrogen ions?
Hydrogen is the cation. That's how we know. Okay? So an acid is a hydrogen, or sometimes we call proton, right? A hydrogen ion. If you take hydrogen atom, has a proton in the middle, an electron on the outside. If you remove that electron, then you just have a proton. So it's a hydrogen or a proton donor. Why would it donate a proton? Because it has one to donate, right? If it doesn't have a proton to donate, we call it a base, but we're not going to get there right now, okay? So an acid is any ionic compound. Let me just write it in easier terms. It's an ionic compound with H plus as the cation. So for example, we have HCl, we have H2SO4. Okay, that H is the cation. We good? Whoa, so is this an ionic compound? That looks like a covalent compound, doesn't it? Two nonmetals? Yeah, that's another exception, isn't it? If you were to get some hydrochloric acid, this isn't hydrochloric acid until we add water to it and dissolve this ionic compound in the water. It breaks apart, and we'll talk about this later. It breaks apart and becomes charged. We says an ionic compound is conductive when dissolved, right? And that's why it's conductive, because the cation and the anion split apart, and now we have a charged solution of water. Does that make sense?
Why is the cation called a donor in this situation? Like, isn't it receiving an electron?
The cation is not the donor, the acid is.
Like, how so?
So, I don't even know if we're going to get to that. We might. Haven't looked ahead far enough. So, but I can show you. So if we have HCl, and let's say we have sodium hydroxide, for example. Then when we're done, and we're going to get into chemical reactions later, I promise, okay? So what happens is this guy gives up his hydrogen, gives it up to this, becomes water. So it just donated his hydrogen.
Okay, makes sense.
And that's what's going on. Okay? So we take, and this is not on this first exam, it's not. If we take a hydrochloric acid, which is a really strong acid, you get this in your eyes or you drink it in high enough concentration, bad news, right? Same thing with sodium hydroxide. This is the stuff we made with the sodium and water, right? If we get this stuff in high enough concentration, also bad news. We put them together, we get water and salt. We could drink it if it's the right proportions, guys. Don't try this. My teacher said I can drink. No, don't do that. Okay? But, are we good? Yeah, Victor.
You said HCl looks like a covalent compound, but it's technically an acid when you add water. Is that right?
Yes. Well, it's an acid when you add water, but it's an ionic compound before you add water. It's a salt. Did we talk about ionic compounds being salts? Yeah. Yeah. It's a salt. Yeah.
Is that covalent bonding through electronegativity, like attracting, like why it forms H2O and NaCl? That's the bonds it wants to form.
So, say that again.
Is that through like electronegativity that it's forming the covalent bonds to make H2O and NaCl? Because it's
Yeah.
attracting to where it wants to go.
Yeah. That's part of it. Uh-huh. And we'll get into that a little bit later. Okay. Any other questions? Yeah, Katrina.
So when the H is first, it's the cation, so does that just automatically mean that it's an ionic compound?
Because it's made of two ions, right?
Yes.
Mhm.
Okay.
That's what tells us it's an ion. Metal and non-metal is the easy way for like 98% of it, right? 98% of all ionic compounds is a metal and non-metal, for example. I don't know if it's 98%, but a lot, right? But 100% of the time, it's a cation and an anion. Okay? Any other questions? Great questions, guys. We learn more when you ask questions, so thank you.
So sorry to recap one more
Oh
time.
my God. No, I'm just kidding. Go for it. I'm just teasing.
I don't know what the takeaway for HCl should be. I feel like there's all these terms that can apply to it, and I don't know.
So how do you know it's an ionic compound?
Ionic compound typically is a metal and a non-metal. But to me, hydrogen is not a metal.
But it is a cation and an anion. And are there cases where maybe it's not? Probably. This particular one, maybe not, but there might be examples. For example, we're going to get to later. Is that an ionic compound or covalent compound? It is a covalent compound, but it has a metal and a non-metal. Oh, you said if it's a metal, there's no exception. There isn't. That's the one exception. Why? Yeah, that one still baffles my brain. So I'm not going to test you on that. But anyway, there's always exceptions, right? Why? Well, we don't fully understand something. Otherwise, we would say the rule is, and that's solid, right? So don't freak out about the exceptions so much. If it's an exception that you need to know, I will tell you. Okay? And I know you're not here just to get a grade and move on. Maybe you want to really learn this stuff. That's where you get into physical chemistry and learn all the ins and outs of it. That was a really cool class. We good? But there's a lot of quantum physics in that class. Okay, here we go. In fact, we're going to learn a lot of quantum physics this semester, next unit, next section. But we're going to tone it down quite a bit. Don't worry. All right, now let's naming acids. We understand how to tell if it is an acid? Okay. So we have two types of acids. We have binary acids and oxyacids. I'm going to first talk about binary acids. What does binary mean? Two atoms, right? Two different elements. What's one of them? Hydrogen, right? Has to have hydrogen if it's an acid. Well, has to have hydrogen as the cation if it's an acid, right? So let me just give you some basic points here. So there's a prefix for binary acids, and the prefix is always hydro. I should write it a little bit different way. Prefix of hydro. So all binary acids will have the prefix hydro. Oxyacids do not have that. So that's how you tell them apart, with their names. Okay, the suffix is always IC. And then we add the word acid to the name. So let's do some examples. What's that called? Hydrochloric acid. It's hydro, because that's the prefix. Change chlorine, change the suffix or the ending to IC, chloric, and then add the word acid, hydrochloric acid. Are we good? Okay, somebody name H2S. Not quite. This is a binary, I shouldn't say two atoms, two elements. So hydrosulfuric acid.
So the number of hydrogens doesn't matter in the name?
No, it's just how many elements there are, yeah.
And the ratio of hydrogens to the element is based off the charge?
Yes, this is an ionic compound, so we have H plus and S2 minus. Cross the charges, H2S. Yeah, great. So we learned how to do this already, right? Same as ionic compounds.
So why is water not acid, but this one is acid?
Because it could be HOH, right? It could be treated as an acid. It could be. Also a base. That's why we call it neutral. It's neutral. It definitely could be an acid, or sometimes is an acid. But I don't know if we're going to get that deep in this class for acids. We might. I can't remember. I'll let you know when we get there. Okay? But even though that's not an ionic compound, water is a covalent compound. Gosh, chemistry's dumb, right? Okay, sorry. It's not dumb, but there's always exceptions. All right, and then we got HBr, HI, and HF. Hydrobromic, hydrofluoric, hydroiodic. Backwards. Good? Are we okay with naming binary acids? And if I give you the name, could you give me the formula? Just like we did here. Right? Write the charge of the cation first, charge the anion second, cross the charges, and simplify. Same thing. Questions? Okay. Next, we're going to talk about oxyacids. And oxyacids are just polyatomic ions with oxygens, right? Oxyanions, remember those? Okay. So last time I gave some of you guys that stayed behind, I gave you a way to memorize the oxyanions, right? Well, we use those for the oxyacids. So let's it's an acid with an oxyanion. So it still has H plus as the cation because it's an acid. Okay. So here's how you're going to name oxyacids. No prefix. We're not going to use hydro. Let's see, no prefix. If the polyatomic ion has a prefix, we're going to use that prefix, right? But for the acid itself, no prefix. If oxyanion ends in ATE, then the acid is going to end in IC. We'll do some examples. If the oxyanion ends in ITE, then the acid ends in OUS. And then we add acid at the end. And that's it. Questions? Not until we do some examples, right? Okay, so let's say we have H2SO4. We can see that this is not a binary acid because more than 2 elements, right? Okay, so we look at the oxyanion, which is SO4. What's the charge of SO4? 2 minus. Okay, good. So what is SO4 called? SO4 2 minus called? Sulfate. Good. So it ends in ATE. That means the acid, we're going to change the ending to IC. So we're going to change ate to ic. That's it. So what are we going to call this? Sulfuric acid. We good? Hold on. It was sulfate. How come it's not sulfic? Because it sounds goofy. No other reason, guys. What about HClO4? Look at your polyatomic ion list and see if you can come up with this name.
Perchlorate.
This is perchlorate. So what's the acid called?
Perchloric
Perchloric acid.
acid.
That's it. What about HNO2? Look at your polyatomic ion list. What is NO2 minus?
It's nitrous acid.
Yeah. NO2 is nitrite. So we're going to end in OUS. Nitrous acid. That way we have just a naming system that we can call these by different names. Good? What's the chemical formula for carbonic acid? H2CO3. How do we get that? It's an acid, so the cation is H+. This ends in icy. That means it's carbonate, right? We look at carbonate is CO3 2-. Cross the numbers down, and we get H2CO3. You with me? So on the worksheet that you picked up today, on section 11, there's a chance for practice. Does anybody need more examples together, or would you like to practice a couple?
I have a question.
Uh-huh.
Is phosphate the only one that would be H3? Nothing else is like
I don't know right off the top of my head. Do we need to memorize stuff like that?
Oh, I don't know.
We don't, because we look at the polyatomic ion with H+, other way around, right? H+, polyatomic ion. We get their charges and we cross them. Whatever it is, it is.
So it's just, the H will always be based off the charge of the polyatomic.
Yep.
Okay. I should ask that instead.
Yeah. You guys want to take a minute to practice a couple of those? I'll be right back.
So I feel like the chemical pictures kind of go. Yeah. So H2 positive. I wonder why I see O3, right? I feel like I've never circularized first. Maybe I should negativity. Well, I was wrong there. It was actually, I think it's through hydrolysis. It's why it goes into water. That's just release. Pretty much where like you break a bond. To form water.
Yeah.
Yeah. But like they didn't say that. Like saying that would make it make a lot more sense. Dehydrated since this is the opposite. Dehydrated, so you're taking it away. Yeah.
I need a purple, or at least red.
It is not in the CD.
So annoyed with them introducing something and then immediately talking about exceptions, it's the fucking rule. I don't even understand the rule, and they're talking about exceptions. Pisses me off, dude. I'm like, I don't care about the exceptions right now.
Probably has to do with like, I bet if you have that from the CD, it's just, it might happen with that, is what I bet exceptions for.
If it's not water and I have H in front of it, it's an acid. That's all I know. Sorry.
That's pretty big to look at
The
it.
name doesn't say that, but the name.
So, is it always an oxy acid if it has an oxygen in it? Is that what makes it? Versus a binary?
Wouldn't it have H in front of it? Wouldn't be H, something,
It would have H.
Any questions? Yeah, Katrina.
So with when you cross the charges for HCO3,
Uh-huh.
you take the 1 and you move it down to coordinate 3 as are you multiplying?
You don't bring it-
The three?
So, just like an ionic compound, that just tells us how many carbonates there are.
But there's already a 3 there, so we just.
You leave the 3 there. You don't ever change the subscripts.
Okay.
So we just bring that 1 down here. And remember, if this was a 2, we would have to put parentheses, right?
That's right, okay.
Right? But since there's only 1, we don't need the parentheses, so we just don't write it. Yeah.
What's an oxyanion again?
An oxyanion is a polyatomic ion with oxygen in it. So it's on our polyatomic ion list. If we have that list on our sheet, then we just look at it, right?
Makes so much sense.
Anything else? Ready to move on? Yeah, Victor.
Question. So for H2SO3, this is sulfur.
Good. H2SO3. Since SO3 is sulfite, ends in ITE, that means our acid would be OUS.
Oh, yes.
Yep. So it'd be sulfurous acid. Questions? Did that answer your question? Anything else before we move on? All right. So that's basically nomenclature. I had a name compound. And the rest of today is going to be talking about the mole. Okay? You guys know about the mole?
It's a rat.
It's that brown spot on your face with hair growing up? No. Okay? It's that little guy in the ground? No, it's not that either. Okay. We ready to move on? What?
It's the spy.
It's the spy, yeah, that's it. All right. So a mole is the SI unit for the amount of substance. Now, you guys are taking the lab, right? Is there any device that measures moles?
I don't know.
The answer is no. So why is this the SI unit if you can't even measure how many there are? And I'm going to show you something today, and we'll probably be tested on it once for this test, but probably never again. It might be tested on the midterm and the final. I haven't checked yet. But we don't use it in, like if I was a chemist, we wouldn't use it. We just use it so that we can make other conversions. So I'm gonna show you what it is and why we talk about it, but then once we get these ratios down, we don't have to worry about it. Sound good? Okay, 1 mole of anything, doesn't matter what the substance is, 1 mole of any substance is equal to 6.022 times 10 to the 23 representative particles. When we learned how to do scientific notation, I gave you this number, right? Huge number. So if we have 1 mole of water, we have 6.022 times 10 to the 23 molecules of water. Molecule is the representative particle. If we have 1 mole of gold, we have 6.022 times 10 to the 23 atoms of gold. Atom is the representative particle of an element, and so on. Good? So let's talk about the different representative particles, and this will, one of you guys asked about, was it Liana? About formula units? Okay. Here we go. So it depends on what we're talking about. The particle name changes. For an element, the particle is called an atom. That's the smallest particle of an element that retains its identity, right? If we have a covalent compound, we call this a molecule. Don't abbreviate the word molecule. Do you understand why? Okay. And for an ionic compound, it's called a formula unit. Formula unit's long, so sometimes we just say FU. Or something like that, okay? And then if we have an ion, it's just an ion, okay? Now, most people talking about particles, they'll use molecules for any compound. But the right name for an ionic compound is a formula unit. Good? So on a real chem, it'll probably need to be formula unit, not molecule, right? But if you're talking to everybody else, they're probably going to just use molecules interchangeably, right? No big deal, I guess. It's just a name. But when I taught 8th grade one year, I don't like teaching 8th grade. But when I taught 8th grade one year, then I misspelled a girl's name. Woo! That was bad news. Sorry. But anyway, so, but here if we call them molecule instead of formula unit, okay, no big deal, right? But for real chem, we're going to need to, real chem's that little 8th grade girl. Be careful. She's feisty. 8th grade girls are scary. You guys know that? Woo! Okay. They are. All right. Any questions on them? Yeah.
So, representative particle, what, I guess I don't know how to explain necessarily what it is, other than, I understand the relationship of what you wrote down, but the term representative particle is what?
It's a particle that represents a given substance, right? An atom represents an element. Formula unit represents an ionic compound. Molecule represents a covalent compound, and so on. Make sense?
Okay.
It's kind of like saying a dozen donuts versus a dozen eggs. The eggs and the donuts are the different representative particles.
They represent something you want to eat raw, or never mind. Okay. We good? All right. So now let's learn how to convert them. Guys, you're going to have to be able to convert this one time on the test. And then we'll move on. Sound good? It's not hard. So if we have, let's say, 3 moles of gold, and I want to know, well, how many atoms of gold do we have? Do we ever care how many atoms of gold we have? Probably not. It's kind of like asking, how old are you in seconds? Who cares, right? For a billion years old, a billion seconds old, I mean. Okay, big deal. But, so we probably won't ever need to do this in real life. but there is a reason we're talking about it. Okay, we'll get there. So this is just a regular conversion factor. What's our conversion factor? Right here. 1 mole equals 6.022 times 10 to the 23 particles. So we're going to start with what we know, 3 moles of gold. And ladies and gents, we talk about units, right? We got to know what we're talking about exactly. If I just said 3 moles, well, we'd be poor if we had 3 moles of water. We'd be rich if we had 3 moles of gold. So it makes a difference. So say what we have, okay? Do we want moles in our answer? No, so where does it go? Yeah, we've done this, right? So moles of gold on bottom. And what are we looking for? Atoms of gold. So 1 mole of anything, so 1 mole of gold equals 6.022 times 10 to the 23 gold atoms. Moles go away, we're left with atoms, so we can stop converting and we just find an answer, right? What is it? 12.066 times 10 to the 23. Is that right? I don't know.
2 times or 3 times?
It'd be 18.066.
Oh, see? This is why you don't do stuff in your head, guys. So what is it?
18.066.
Or 1.807 times 10 to the 24
Yep.
atoms of gold. Yeah. Use a calculator. You have one right there. Just use it. It's easy. Do you guys know how to type this in your calculator? Did we talk about this? Should we show you? Okay. Some of us need help. That's okay. So we're going to type in 3 in our calculator. Then, since this is on top, we're going to push the multiply button. And then we're going to type in 6.022. How do you write times 10? EE or EXP or whatever the button is. It might even be times 10 to the X, right? Whatever it is. And 23. And then the equal button. Make sure you can do this. And if you forget how to how to type it in on your test, guys, wait, you're not going to take the test in here, so never mind. You need to know this. Yeah.
Can we use sig figs, right? 4 sig figs?
Yeah, so what should it be?
So it is correct if you did 1.807.
So maybe it should be 2, right? Because we have 3 moles. I don't know. 2 times 10 to the 24? Sure. We're off a few dozen, or maybe a couple hundred atoms. Are we going to notice? No, we're not. So yeah, maybe it should be 2 times 10 to the 24 atoms of gold. Good? Do you understand why? Because my measurement was 3 moles. And really, that's not a measurement, guys. We'll get there. We're starting there, so we're going to call that our measurement. Can we all type this in our calculator? All right. Should we take a break? Take a break, finish it up. We might finish early today. Remind me your name again?
Seth.
Seth.
I just transferred in
Yeah.
last week, so.
Okay, that's good.
Professor, so does that mean that most polyatomics are oxyanions, since most of them have oxygen in them?
Yeah, this one isn't common. We don't use these for acids. I guess you could. Dichromic acid. I've never heard of it, but yeah, okay, yeah.
Permanganate.
Permanganate.
Permanganate. Have you seen that meme where it's like Perganante? Permanganate. I'm Perganante. It's like a woman trying to say she's pregnant and she says, I'm Permanganate. One of the times. It just reminded me of that.
Man, I can never focus on the cool stuff about it, cause a certain time, like it's so stressful, dude. Half the time I just do everything that I'm just like, the heck's going on?
Quick question for you about this
Mhm.
feedback follow-up quiz thing.
Yeah.
I don't know if I received explicit feedback.
Okay.
What is it that I'm
Once
looking
you
for?
once you do that quiz, then I'll give you feedback.
Oh, it's after you do the quiz?
Yeah, so because it's only worth 13 points and the whole assignment is worth 23 points. So I'm going to give you 10 points once you submitted your Feynman notes and that.
Okay,
Good?
I believe so. Yeah, I did this. Okay, awesome.
Yeah.
I'll just do it then. Thank you.
All right.
Two Canvas related questions for you. One, I think I talked about this last time, but the post-test thing. Sorry.
Someone's gonna die. Okay.
The post-test reflection, can it be open longer? So that, cause I'm planning on taking
When is the last day? Yeah, you did talk
the
to me.
8th, and it's only open till the 5th. So is that
Yes. Will you email me?
100%? Yes.
Because I forgot
I'm
about
the
it.
same way. Okay.
Okay.
And then the other one was the Feynman,
Let me talk about that
one-
because you're the third person asking. So.
the reflection getting awesome.
Yep.
Thank you.
Chris, maybe I didn't understand it. For the Feynman no reflection, you submit the quiz answers first, and you answer on for the
Yep. So if you've already submitted your Feynman notes, then you do that little quiz, and then I'll give you the rest of the points.
Okay.
That'll tell me you're ready for me to check it out.
I just made this one. At least I
Yeah, it wasn't very straightforward, so.
Yeah, because it said like things like do not do the quiz until you contact them, and I was like,
I didn't.
I don't see it yet.
I know, I started
Okay.
playing it.
Maybe I misunderstood. I didn't write it, but
This one is
we'll do it that way.
Okay.
I'll tell everybody as soon as we get back.
You said we should take our first exam by this weekend?
Yeah. Yep, by the 8th of June. Yep. Did everybody get the lockdown browser on your computer?
Unfortunately.
We can do that in the library too, right?
Yes. If you don't want to download on your computer, yeah, go to the library, or you could even check out one of their computers, right,
Okay.
for the semester.
That's what I was gonna do.
Yeah.
Is that your account or?
10 minutes takes a whole long time when you're waiting for it, doesn't it?
So you're still, wait, did you start thinking? Oh, dude. Oh, yeah, that's not the, it's like a 7-year batch. I do quit for a while, cause it's just, I don't know, there's so much. Yeah, every once in a while, I'll just put. Oh, yeah, dude, I love this spam. Yeah, dude, this one was worth it. This for it. Yeah, this is new, dude. Yeah, they added so much new stuff. Which is great. Did anybody play Couch or Couch games?
No,
Oh, no.
I don't have that type of system.
Alright. You don't play mobile games.
Excuse me, sir. My system is completely fine.
I remember you told me about that.
You gotta play.
It's pretty much just my chess. Oh, seriously? Yeah, I'm only playing Clash games, that's about it. Play Clash Clans.
Never got into it.
Yeah, right, just upload them once every day for like 2 minutes, upgrade stuff and hop on.
Once a year.
Since I'll sell my account for.
You're like deep in the game.
Yeah, dude.
I mean,
Dude,
dude.
I'm just doing it so I can sell my account. So it only takes 2 minutes to play.
They usually play 6 months here, 6 months there, because they're getting older.
All right, do we have everybody back? Looks like it. All right. Any questions on converting from moles to particles? Can you do particles to moles? So far, we're given 1.76 times 10 to the 26.
They're not screen shared anymore.
Uh-oh. Thank you. (1.76 times 10 to the 26 molecules of water. I want to know how many moles of water. Did I spell moles wrong? That's the abbreviation because it's such a long word. We can abbreviate that, but not molecule. Weird, huh? Oh, yeah. So we're going to start with what we know. So long. But write everything. You might think, I'm okay, I understand. But then we get, later on, we're going to be dealing with stoichiometry. We're going to go from grams of one substance to grams of a different substance. And if you try making shortcuts, you might mess up on the units at the end. I don't know. Okay? Just be careful. I would suggest that you write it all out. Takes a minute, but it's only a minute, guys. Do we want molecules in our answer? No. So how many molecules goes on bottom? 6.022 times 10 to the 23 molecules of water to 1 mole of water. Then we just divide those two icky yucky numbers. Yeah, so 3 sig figs, 292 moles of H2O. That's a lot of moles.
Isn't it 0.292?
No. And here's how you can recognize this is 10 to the 26 over 10 to the 23rd. No, that's good to look at that. Does your answer make sense? 10 to the 26 over 10 to the 23rd. Well, 23 goes away, and then you have 3 left. That's on the order of 1,000. But then you have a small number divided by a bigger number, right? So, yeah, okay. Good? Any questions about particles? Okay. Which of the following has more atoms in 1 mole of substance? Sodium carbonate or copper 2 sulfate? Any ideas? A or B? Which one has more atoms in 1 mole of that substance? What?
Should be B, right?
Why?
Because there's more atoms in one molecule.
That's right. If we're going to convert molecules to atoms, right? We can go 1 mole, convert it to molecules, right? And convert molecules into atoms. There, 1 copper atom, 1 sulfur atom, and 4 oxygen atoms. That's a total of 6 atoms per molecule. I abbreviated it. You following? This has 2 sodiums, 1 carbon, and 2 oxygens. That's 5 atoms per molecule. Hold on, that's not a molecule. That's a formula unit, right? See where it doesn't matter? It's just a name. Maybe we should just say FU, right? It's shorter. Good?
So when it's saying atoms, it means like type of atom?
Just means atoms in general. If it said gold atoms, then it would be specifically gold atoms. But this just says atoms.
So we would just count the elements?
How many atoms there are in one compound, 1 molecule, 1 formula unit, right? Can we use dimensional analysis for the whole thing? Sure. 1 mole of Na2CO3, and in 1 mole of Na2CO3 has 6.022 times 10 to the 23 formula units of Na2CO3. And in 1 formula unit of Na2CO3, we have 5 atoms. You with me? So really, we just do 5 times this number. What are we going to do over here? 6 times that number. You good?
Yeah, that's what I was thinking, yeah.
Yeah. Okay. Now I'm going to show you why we learned this and why we don't need to use this anymore. Since it's 6.022 times 10 to the 23 particles of 1 mole of anything, then let's see. If we're dealing with water, what's the ratio of atoms in water? 2 atoms of hydrogen to 1 atom of oxygen, right? You with me? Wonder what the ratio of moles is. Moles of hydrogen to moles of oxygen. Is it the same thing? 100%? Let's figure it out. Make sure we know. If we have 2 atoms of hydrogen, I'm just going to do one at a time. And I know there's 6.022 times 10 to the 23 atoms in 1 mole. Atoms goes away and I'm left with moles, right? Then let's do 1 atom of oxygen doing the same thing, right? 6.022 times 10 to the 23 atoms of oxygen to 1 mole of oxygen. You following me? I'm going to get a number here, right? And a number here. Can I just say the ratio is that? Whatever we get here over whatever we get here? Is that the same thing as this divided by this? What cancels? That ugly number. 2 times 1 is 2 moles to every 1 mole. Will it be that way on any compound? Yes. So rather than saying 2 atoms of hydrogen to 1 atom of oxygen, we could just say 2 moles of hydrogen to every 1 mole of oxygen. Then we can skip the whole step of converting atoms or particles into moles. Isn't that nice? Easy. Since they are the same, since we know that they're the same, we don't ever have to use that icky, yucky number ever again after the test. Good?
Then why do
Yeah.
you not use it in the rest?
Because moles, you guys know what a mole is? Can we measure moles? No. That's why. So we can wrap our brain around it. Yeah, it's okay. That's it. Yeah.
So it's always the same because it's always measured by like the equivalent of like 12 C's or something. So it's like this weight in 1 mole is always equivalent to this weight in 1 mole. So it's operating weight. Like depending, sorry, like,
The weight's not the same.
okay.
We'll get there. So if we have, I don't have these right here, but I'm just going to kind of draw them for you. If we have a container of water and we have 1 mole of water, it's going to fill our container that much-ish, okay? It's like a beaker, right? If we have that same beaker and we put sugar in it, C12H22O11, it's going to fill it up to there. But it's 1 mole. Whoa, 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 whoa. Why is this so much more if it's both 1 mole? They're bigger. You with me?
So it's not weight, it's What exactly is the mole measuring?
Mole is just the amount of substance, not volume, not grams.
So like,
It's particles, really, right?
so like 1 mole of H2O would be equivalent to 1 mole of sugar, but the size is different?
They're not the same.
Okay.
The number of particles is the same. This is 6.022 times 10 to the 23
Okay.
molecules of water. And this is 6.022 times 10 to the 23 molecules of sugar
Okay.
or sucrose,
That puts it all together.
okay? But they do have a different mass, different size, different, okay? But since we don't have to use this anymore, let's don't. Okay? Any questions on that? Okay, now let's do what is useful. Here's the useful stuff. Now, that was useful just so that we understand it. We all understand it? Okay, now we never have to do it again because we know it, right? All right, let's talk about molar mass. Sometimes called formula mass. Or I think the book or the test might call it formula weight. Are weight and mass the same? No, but it seems like people just interchange those, just like what? Molecules and formula units. It's just a name, right? But they are different, yeah.
Where did AMU come into all this?
Uh,
Also on the real count.
Probably some guy that wanted to make it harder than it really is.
Yeah, the real count was confusing. There's like 3 or 4 different.
We're gonna get there. Did we talk about AMU in this class?
Yeah, you told us how it's like silly.
Yeah, it's dumb. But you still need to know it. Still need to know what it is. Because it's like, I don't know why all the books are written that way. I just don't understand it. Why don't we just use what it is, right? But anyway. So it's the atomic mass unit. But anyway, molar mass, formula weight. This basically is what? The atomic mass of our compound. Now that doesn't make any sense. Atomic mass, atom, mass of an atom of our compound. But it's the same thing, okay? So for example, if we have sodium chloride, for example, what's the atomic mass of sodium? Somebody look it up. Everybody look it up on the periodic table. What is it? 22. Should we round it? Not until the very end. If you want to get a better, more accurate number, right?
If we round it, would that be the mass number? Aren't they not the same? Or,
They are not the same. This is the average.
because the other one is for the
Because if we have,
isotopes.
yeah, if we have a handful of carbon, is it going to be all carbon 12? No, some of it's going to be carbon 13. So we don't know how much, but we'll just say on average this is what it is. Okay? And what's the what's the atomic mass of chlorine? 35.45?
Yes.
Okay, so just add those together since there's one of each. And what do we get? Something.
58.44.
58.44 what?
Atomic.
Grams
Per mole.
per mole. And the book might use AMU, right? But that's not useful. So we'll use grams per mole. If you have 1 mole of salt, it's going to have a mass of 58.44 grams. Okay? And we could do that with any substance. So what about water? What's the atomic mass or the molar mass of water? The formula weight, formula mass of water. Everybody, figure this out. Y'all get that?
Yes.
So we have 2 oxygens, we have to multiply its atomic mass by 2. Good? Yeah, Gavin.
So, I was kinda asking a question earlier, because it seemed to care a lot if it was formula mass or molar mass for like grams per mole, AMU, or like whatever. Is that gonna matter on the test? And if it does?
Okay. So you just have to look at the unit. AMU and grams per mole is exactly the same thing.
Right, it is the same thing, but it still marked you wrong if you didn't pick the right one, which, on the real chem.
Yeah, so if it gave you this number in AMU versus grams per mole,
Like if I would've used the molar mass, so the grams per mole, instead of the formula mass, which is whatever.
molar mass and formula mass are the same.
Right, but then it wanted a different, what do you call it at the end?
Unit?
Unit, it wanted a different unit, and it marked me wrong.
Okay, if it asks for AMU, then make sure it's in AMU. If it asks for grams per mole, make sure it's in grams per mole.
Well, it didn't specifically ask for it, it just said like, here's a compound, and then like, find the formula mass, or find the molar mass.
Well, did you have to type in the unit, or was the unit given?
I think it was a multiple choice, and you had to pick the right unit.
And grams per mole was one of them, and AMU is one of them, with the same numbers?
It was
You
something-
might want to bring that up to me, because if it was, that's nuts.
It was on the, it had something to do with the checkpoint for this module, 2.4, it was like,
I went through, maybe I didn't go through this one, because it was straightforward in my head, but if you want to send me a screenshot of it or whatever,
yeah.
that'd be useful. Because unless I know what it really was, I can't really tell you.
And I just asked that because I know like we're interchanging it in class, but I was just didn't know if it would matter for us to really know the specific.
They are exactly the same. So if they put both of those options on there, then that's going to change my opinion about real chemistry. I'm just kidding. No, it's good. We good? All right. Can y'all figure the atomic mass or sorry, molar mass or formula mass? There's more examples on here. If you want to do them, should we do one for? Let's do a harder one. This is on your worksheet, section 14. CA3 PO42. Who can tell me what that's called? You have to know what that's called. So what's it called? Calcium phosphate. Okay. All right. So what's the atomic mass for calcium? 40.08. What are we going to do with that? Multiply it by 3. Phosphorus is it about 30 point something?
Yeah, it's 30.97.
Multiply by 2, because of this guy right there. Plus oxygen is 16, multiply by
Well, it's gonna be 8, right?
8. Yep. And that's going to give us a value, whatever that is. That's the molar mass, or formula mass, or formula weight, whatever one they use. Should just stick with one name, huh? We're finding the molar mass. What should we round to? Because we're not given any. How many decimal places should we round this to? 2 decimal places. That's all the atomic masses are, right? Anybody get an answer yet? 310.18 grams per mole. What can we do with this, guys? Any ideas? Convert what? Convert grams into moles, or moles into grams. That's it. So our periodic table is full of these conversion factors. That's how we can go from grams of one substance to grams of another substance, because we can find these molar masses and do it. We're not there yet, but that's how we can do it.
And that's because mole's universal.
Yeah. And the molar masses are on the periodic table. We can calculate them. So if we have 30 grams of sugar, or let's do 30 grams of calcium phosphate, so we don't have to calculate anything else, right? And I want to know how many moles this is. Why? Do I care how many moles? Can I measure that? No, because this is just a preliminary step to getting from grams of one substance to grams of another substance. This is just one little step. So can we convert this into moles of calcium phosphate? 2. Of calcium phosphate. Do we want grams in our answer? No? Goes down here. How many grams? Is it 1? We're going to convert to moles, right? This is grams per how many moles? Doesn't say, but it means 1, right? So 1 mole of calcium phosphate has a mass of 310 point, is that 18? So that goes away and we're left with moles. There we go. How many moles is that? Point 0.096. How many sig figs should we have? 1. 0.1 moles of calcium phosphate. Are we good? Do we understand dimensional analysis yet? Okay, we've been converting standard units to metric units, metric to metric. Now we're getting into the chemistry conversions. We use this the rest of the semester. Make sure you can do this. Okay? Yeah.
Our grams per mole calculation, shouldn't it be 4 sig figs versus we have?
Oh, for this?
No.
Is that what you're wondering?
Yes, when we calculated that.
Yeah, that's a good question. Do we go with our measurement or do we go with our conversion factor?
No, I think when we do the conversion, we go with the full number without any rounding. But if the question was only the blue part, it would be 4 sig figs, right?
Sure. The only reason why is because our atomic mass is only 2 decimal places. We're just adding, right?
Oh, that's right. Well,
So, but really, they're just conversion factors. And as far as we're concerned, our conversion factors have infinitely many sig figs.
oh, okay.
Does that make sense? So we're not going to include our conversion factors in how we're going to round. So if I have 30 grams of this stuff, that's the only measurement that I have. I measure it out and I get 30 grams. Well, if I use a more precise equipment, I might get 29.742, right? And if I do get that, my scale reads that, then I better have more digits. Does that make sense? Yeah.
You were saying 1 mole makes it 1 sig fig. That's not like a precise, or that's not. Is that what you're saying?
No, I'm saying this is 1 sig fig. So we better round our answer to 1 sig fig. You're Evan, right?
Yeah.
What'd you-
I was just wondering how you got like 30 grams of,
That was our given value.
what?
That was our given value.
Okay, great.
And our given value is usually our measured value,
So it is,
right? Like if we're doing this in our lab, how would we get 30 grams? We'd take it to the scale and put it on there and measure it, right?
Gotcha.
Liana?
How do you, like, I understand how you get the 310 number, and then when you plug that in, why do you not have to have grams per moles?
It is.
Wouldn't that be moles per gram?
No. This is a conversion factor. So it's 310.18 grams per 1 mole,
Oh,
right?
yes.
Can I flip that if I need to? Yeah. Thanks for asking that question. Anybody else?
I'm sorry, I guess, so why isn't 30 grams 2 sig figs? If it's 2, is it because you said it's.
Because there's no decimal, and the zeros to the right of a number are only significant if there is a written decimal.
Oh, yeah.
That's just one of their sig fig rules.
So if it was like 30 points?
Then it would be 2 sig. If it was 30.0, then it'd be 3. So these are just rules. Who made up these rules? Men or women, right? We made these rules up. And we says, okay, this is the way it is. If everybody's on board, this is the way it is. This is how we're going to do things. And that's why we do this. Okay? Maybe later down the road, someone else says, you know what, that's a bunch of bull crap. Let's change it. Then we can change it, sure. As long as we're all on the same page, right? Are we good? Do you want to do another example? How are you feeling? Yeah, Carla.
Is calcium phosphate an ionic compound?
That's a great question. What do you guys think? Is calcium phosphate ionic or covalent? How do you know?
It's ionic, 'cause it's a metal.
Calcium is a metal. And phosphate is an anion. Therefore, it must be ionic.
You said it's polyatomic, right? So all
It is, yeah.
polyatomics are ionic.
N- Not quite. All compounds with polyatomic ions in it are ionic.
Okay,
But polyatomic ions by themselves is a covalent compound.
right. The charged covalent compound?
Yep,
What do you say?
yep. Any other questions? We still have 35 minutes, guys. Should we just, what do you guys want to do? Go home?
Maybe do one more and then go home.
Okay, yeah, we can do another one. And guys, that's all I have for you. If you're good, you're good. Go for it. But if you want to do another practice, let's practice.
Wait, can I ask one unrelated question?
Yeah.
What was the answer to the, how do you answer the Feynman?
Oh, yes, thank you. I appreciate that. See, I already forgot. Okay, so on your Feynman notes, you have to turn in your Feynman notes, right? And then there's another one for me to say, give you feedback on it, right? And the instructions might be different than what I'm thinking in my brain. Here's what I'm thinking. Turn in your Feynman technique, or your Feynman notes. Answer the quiz questions. Once you do that, I will look at your Feynman notes and give you feedback. Because it's a little bit easier, because all you guys' posts are in the same thing, right? It's a little bit easier to say, okay, rather than scrolling down, finding yours, just go to the next assignment, and you could read my input.
So do you want us to like, I just pulled the thing up and the last question is paraphrase the feedback, highlighting the main points and suggestions for improvement. So do you want us to just resubmit our Feynman notes in that so that you have it in a
Sure, that would,
second place?
oh, that'd be ideal.
Okay.
But either way, and here's how I'm grading that. If you did your Feynman notes and you did that little quiz, I'm gonna give you full credit, even if your Feynman notes suck. But what are the Feynman notes for? Who are they for? You or me?
For us.
For you. It's just a study technique, guys. So, thank you. I'll give you my feedback, and you can take it for what it's worth. Okay? We good? Also, the exam, or exam 1, unit 1, 1.1 and 2, is going to be for this next weekend, right? So try to have it done. Also, there's a pre-test bonus point quiz. Do it. I would do it, guys. It's easy, and it's free points, guys. It's just free points. So do it. Now, it's only worth 1 point right now. After the midterm, I'll put in 10. The reason I'm not putting 10 in right now is it would just swamp it'd just make, oh, I'm doing fine in here. I don't need to do anything in here. And then you just kind of gradually go down. That's the only purpose of waiting, okay? It really will help your grade. I would definitely do it. That's like extra 10 points on an exam, okay?
Just to confirm, the test opens Friday morning and closes Sunday night.
I think it opens right now.
It closes the 8th.
And it closes on the 8th. And, yeah.
So sorry, just because I haven't been able to get on Canvas, is the Feynman notes just an assignment kind of on there?
It's just a study technique.
Oh, okay.
So if you look on the, I think it's on the pre, like the point 1, point 2, unit 0 section will kind of explain how to do that.
All you do is the Feynman technique, it's like where you pretty much like write out like a diagram.
Do you want to do one more? Okay, here we go.
And so you pretty much like write a diagram.
If we have 4.8 moles of sodium chloride, I want to know how many grams.
And that one's just
Thank you, take care. Where are we going to start? What we know, 4.8 moles of sodium chloride. Now, someone says molar mass. We do need to calculate the molar mass, don't we? Well, we already did this, didn't we? There it is. Oh, 58.44. So where does that go, top or bottom? Well, let's see, 58.44 what? Grams per 1 mole. So it goes on top. Not because that's how I wrote it. It's so that we get moles to cancel out, right? That's it, guys. Thank you. Straightforward or no? It's just a conversion factor. I know it's funky units you've never seen in your life, except for, well, maybe you have, but it's relatively new stuff, right? But it's just as easy as converting inches to feet, once you know the conversion factor. Except for using, what?
We have to round it to sig figs.
2 sig figs, yep.
So if we get 280.5, that's gonna be 280.
200, yeah, it'd have to be 280. Because it rounds to 281 if you look for 3 sig figs, right? but we're not. We're just looking to there. 2 sig figs, and so that 0 tells us to round down. Yeah.
So is the
Further.
molar mass always gonna be equal to that 1 mole?
It's not equal. It's molar mass is how many grams per 1 mole. Always. Not per 3 moles, not per 9 moles, but per 1 mole. Any questions on this stuff? And I brought this out this time because it's in real chemistry, but it comes up again when we start using it. So we'll kind of refresh ourselves a little bit.
Thank you.
Take care, Milos.
Have a great day.
You too.